Well, it's Mr. Eckstrom again. More physics basics. This will be the last of our physics basics, and we'll move on to some more ideas and concepts from actual physics itself. Another tool, I'm going to introduce another tool to you. It's a very powerful strategy for approaching problems, is what it really is. It's a problem-solving strategy that I've sort of invented just by looking back over my past and asking myself, how did I get to be fairly successful at solving problems? And I'm trying to pass it on to you. The method is called, it's called the APCE method. I actually have a name for it. APCE. And you're going to see what each of these letters stands for as we go through here. The first one is A, and that stands for analyze. The first thing to do when you approach a problem, ask yourself, what do I know? Look at the problem, if it's a written problem, and write down the given information. What is it that I know? What are they telling me? There may be some stuff that's hidden there too, so read problems carefully. If it's a real life problem, you still ask yourself the same question. What data do I have available to me? The second part of analyzing a problem is ask yourself, what is my job? What is it that I'm supposed to find here? Without analyzing the problem, you really don't have any place to start at all. This is the first step. It certainly isn't the end of it, but without knowing what you know and what you have to find, you can't progress from there at all. The second step is to create a plan. Most people skip over this step and just try random stuff until they get stuck, then ask their teacher or a smarter student for help. You need to make a plan or you're never going to get your answer. This is a good strategy for making a plan. The first thing I want to do is ask myself this question. Do I know an equation that relates what I need to the stuff that I know? A really good idea that's helpful here is when you're writing down, when you're back in that first step and you're writing down the things that you know and the things that you need, use symbols. Because the symbols are what are in the equations, and it makes it easier to pick out the right equation. For example, if what I know includes a mass, write down m equals, 2.5 grams or whatever it is. If it's a speed, write down v equals 5 meters per second. Write it down in terms of these symbols that are familiar in physics, and that'll be easier then to find the equation that you need. Sometimes one equation isn't enough, and so you have to ask yourself a second question quite often. Can I use more than one equation to bridge from what I know to what I need? For example, let's say we have an equation that A equals B times C, and I know B, but C is still an unknown to me. Well, I may have another equation that says C equals D divided by E, and I know D and I know E. So I can use D and E to find C, and then my plan will include plugging C in here and then ultimately getting A, which is my answer. So think about that as well. Finally, when you've got a plan in place and you've analyzed your problem, compute. That's what the C stands for in APCE. This is the time when you pick up your calculator and find the actual answer. Most students like to try to skip straight to this step, and sometimes they're right if it's easy. Sometimes they're wrong. Quite often they're wrong when the problems get hard if they don't have a strategy. So your third step only comes after an analysis and a plan. You insert your data into the equation and solve. So whatever m is in the equation that involves m, you put a number in there. It's very important that you keep your units in the calculations for any but the simplest calculations, because units help you with the next step, and that is figuring out if you actually did this right, if your plan is going to be successful. This is a step that many people skip. Even I sometimes forget to do it, but it's very important. Ask yourself, did the units come out right? This is the E part of APCE, and it's evaluating your answer. Don't just accept it because the calculator has it on there. Don't just accept it because you're hoping. You can know if you have a reasonable chance that your answer is right. First thing to ask, did the units come out right? If the units are centimeters and you're supposed to be measuring, mass, that's wrong. If it's miles and you're supposed to be measuring volume, something went wrong. That's where putting the units in with the calculations is very helpful. Then sometimes you can answer this and sometimes you really just don't have a feel for it. But if possible, ask yourself this question. Does the answer make sense? It's a common sense kind of a test. For example, here's a good example of a problem that some AP chemistry students of mine have done over the years. They analyze an aspirin tablet which weighs 1 gram, and they're supposed to figure out how much aspirin is in it. Well, if you get an answer that's 5 grams, that doesn't make any sense. The whole tablet only weighs 1 gram. It can't possibly contain 5 grams of aspirin. That's the kind of thing I mean when I ask you to ask yourself, does the answer make sense? Sometimes it's nonsense. Sometimes it's very clear. It isn't always. All right, so let's use an example here. Let's apply the APCE method to this question. The question says a car travels 60 miles per hour for 30 minutes. Well, here's some things that I know. I'll write down what I know. Make a little list here to organize my problem. 60 miles per hour is a speed, so I'll say V equals 60 miles per hour. For 30 minutes, well, 30 minutes is a time, so T is 30 minutes. I can also analyze here what I need, because it asks me very specifically how far does it travel in this time. So D is the symbol that represents how far, distance. That's what I need. Now, that's my analysis. That's the A step, is what I just did there. Now I need to make a plan. Well, what's my plan? I have to ask myself, do I know an equation that connects these things? In fact, I do know an equation that connects density, velocity, and time. Density, speed, and time. And that is that, or not density, distance. Distance equals speed times time. All right, so there's my plan. I'll take my speed, my time that I know, I'll plug them in here, and I should be able to get distance. So now I'm on to the compute step, the C step. Plug the numbers in. If distance is speed times time, that means in this context, distance is 60 miles per hour times my time of 30 minutes. Notice how I'm not just multiplying 60 by 30. I put my units in here, and that really helps me because right away I can start evaluating before I even punch the numbers in my calculator. I know that minutes and hours are not going to cancel. So the unit I'm going to get is a crazy unit, mile minutes per hour. It's distance, but it's not anything that we're comfortable with for distance. Here's where I can just keep going. I can add a step from what I learned in the last video, and that is dimensional analysis. I'll just convert the minutes into hours right here by tacking on this factor. 60 minutes is the same thing as 1 hour. So by putting 1 hour here, 60 minutes down here, hours cancel, top and bottom. Minutes cancel, top and bottom. And the only thing I have left is miles, which is a very reasonable unit of time. Well, 60s also cancel, it turns out, so I don't even need to grab my calculator for this one. The answer will come out to be 30 miles. Okay, now, evaluate. In this case, I can evaluate. I know my miles are right. I've already taken care of that. We all have a pretty good feel for driving around in the United States where we measure our speeds in miles per hour. If you drive 60 miles an hour for half an hour, you've gone 30 miles. So, yeah, this passes both the unit test and the common sense test.